So one of the things that comes up when you're dealing with polynomials is sometimes we try to make our polynomials simpler by taking roots out. Well, to take a root out, okay, to get rid of a factor, okay, remember factors are just things that are being multiplied. Well, how do you unmultiply? Well, you have to divide. So these are three examples where I'm taking one polynomial and I'm dividing by another polynomial. And we need to know how to do this division. So for starters, I'm going to show you polynomial long division. Now, there are other types of division for simpler problems, but really, whenever you've got a polynomial like these two guys, really your only option is this, is polynomial long division. Before I show you polynomial long division, let's make sure we remember regular long division. So let's say we've got 25 divided by 7. Or let's do a little bigger. We'll do 250 divided by 7. So 7 goes into 2 no times. 7 goes into 25 3 times. So we get 21. And we have 4 left over. We'll do 40 plus 0, basically. And then 7 goes into 40 how many times? I think it's 5 times. So we get 35 and 5 left over. So this is our quotient and this is our remainder. Now we could write this as 35 remainder 5. We could also write this as 35 plus 5 sevenths. Okay. Either way, what this means is 35 times 7 plus 5 would get us 250. Because this is our quotient and this is our remainder. All right. Now let's see what this looks like when we start to do it with polynomials. So I'm going to attempt this division right here. So x to the third plus 7x squared minus 2x plus 5, x minus 4. Now, I'm trying to see how many times does x, what do I need to multiply x by to get x to the third? Well, I'm going to have to multiply by x squared. You'll notice I put it above the x squared. So I get x squared minus 4x squared. But I'm subtracting, so I'm going to go ahead and switch both of these signs. So, it's the third. So this should be 0. This is 11x squared. And then I drop down this negative 2x. Well, what do I need to cancel out an 11x squared? Well, I need to multiply this by 11x. So I get 11x squared, and I get negative 44x. But I'm subtracting this, so I switch both of these signs. So this is 0, this is 42x. Drop this down. X times what gets me 42x? Well, that would be 42. So get 42x. What's that? 168. Negative 168. But we're subtracting this. So we switch those signs. So this is 0. This is 173. So our final answer here would be x squared plus 11x plus 42 plus 173 over x minus 4. Okay, so our remainder was this, so we just put it over our divisor there. Let's try a bit of a nastier problem. Okay, Because this is a problem that you'll find out later that we could have done with synthetic division, but this is a problem that we couldn't. So it's actually more important that we know how to do the hard ones than it is to know how to do the easy ones. So let's see. 5x to the fifth plus x to the fourth minus 31x to the third minus 5x squared plus 30x. And I'm going to put a plus 0 just so we can acknowledge that there's nothing in that spot right there. And I'm going to do x to the third plus 0x squared minus 5x plus 0. Again, you don't necessarily need the zeros, but that's just going to remind you to leave a space. All right, x to the third. How do I get that to become 5x to the fifth? Well, I need a 5x squared. So I get 5x to the fifth. I get negative 25x to the third, and then everything else is zeros. But I'm subtracting, so I switch these. This is 0. What is this? Negative 6x to the third. And then I'm going to go ahead and bring both of these guys down. All right, so now I need an x to the fourth. And I have an x to the third. Well, how do I do that? With x. So x to the fourth minus 5x squared. I'm going to be subtracting, so both of those swap. So we get negative 6x to the third, and then 0, and then 30x. Again, you don't need this, but I'm just keeping track that there's a gap there. All right, well, how do we get x to the third to become negative 6x to the third? Well, with a negative 6. So negative 6x to the third, 0, positive 30x, and then we switch these signs because we're subtracting. And we're left with nothing. Yay, we have a remainder of 0. What this means is we could rewrite this polynomial right here as 5x squared plus x minus 6 times x to the third minus 5x. Okay, we've succeeded in factoring out this guy just a little bit. If we needed to, from here, I could solve these two guys, and I could solve for those 3 roots as well. So getting that one step got us a lot quicker to, a lot further in finding these roots if we needed to. But this is our solution right here, okay, after we divide. So let's check out this guy. And the only thing that makes this one a little weird is we have some imaginary coefficients, and we're also dividing by something with a real part and an imaginary part. So let's try this guy. All right, so what do we need to make 2x equal 6x cubed? Well, I need 3x squared. So 6x cubed, 12ix squared. Oops. I'm subtracting. I get 0. Hey, that's cool. So plus 8x. What do I need to get this guy to be, well, might as well bring down this guy as well. So what do I need? Well, let's back up here. No, we're good. Sorry about that. So what do I need to get 2x to become 8x? Well, I need 4, not 4x. So we can abandon that spot right there. Okay, it's going to be 0x. I need a 4. So this is going to give me 8x plus 16i. Subtract, 0. So my answer is 3x squared plus 4. Okay, so no remainder, just 3x squared plus 4. So polynomial long division, it's a little tedious, but it's actually not too bad. It's that same algorithm you learned for long division back in middle school. It's just got polynomials involved.